So today we're going to discuss topic 7, question 14. All right, as you still remember, previously I asked you to hold on to the graph, right? Question regarding the graph. So today we're going to discuss the questions here. Lah. Right, questions 14. Progressive wave represented by the equations given here, all right, where x and y are in meter and t is in second. So A, they ask you to calculate the wavelength. So this one, we straight away compare equation with general progressive wave equation, which is A sine omega t minus plus minus kx. This is the equation. Now, but one thing you have to be careful with the equation here. So we have to expand the equation first. So then only we can compare. So if I expand the equation, I will end up my equation will become 0.5 sin 2 pi t minus with 4 pi x. This is my equation after I expand 2 pi. Alright, I expand 2 pi into the equation. So from here we can compare directly. So the first question they ask you, A1. So they ask us the wavelength. So to determine the wavelength, we look at the wave number here. So wave number here, if we compare wave number with the equations given, so my wave number here, equation wave number would be equals to 2 pi over lambda, and the wave number from the equation is 4 pi. So from here I can cancel out. So rearrange my equation, my wavelength I will be able to get 0.5 meter. Right? 2, it asks us to find the period of the wave. So period of the wave we can compare directly with omega and the equation here. Right? So we know that equation for omega is equals to 2 pi over t. And then the equation, the value of omega from the equation is 2 pi. From here, I'll be able to cancel out. I'll end up my period will be 1 second. Now for B, this is the part where I need to focus on the equation itself. Now equation this time, I'm going to refer to this equation that I've expanded. Right? So the equation say, sketch the graph for particle x is equals to cos 0.5. So if you refer to the equation, let me copy the equation first. Now, one thing you have to notice that you have to know that when you talk about the equation, right, there's three unknown here: y, t, and x. Three unknown. So if you want to sketch a graph for certain axis, for example, this one, displacement against time, or y with t, that means that another unknown here, x, must be of constant value. So we have to make it unknown to become known. That means that we have to substitute value. So if you want to sketch graph y against t, I must have a value of x to substitute in. If I want to sketch the graph y against x, I must have a value of t to substitute in. So this one won't become unknown. All right, that's the thing that we need to do. So if you want to plot graph y against t, that's why they give you the value of x. So by substituting the value of x, the first part, so my equation is when x is equals to 0, right? X equal to 0. So my equation will looks like this: 0.5 sin 2 pi t, then 0 here. I'm going to substitute here as 0. So what we can see is the ones will be 0, nothing here. So in the end, my equation will become 0.5 sin 2 pi t. Now from this equation, I can use it to sketch my graph. So from here, this is your x and y axis. So y axis will be y, t axis will be your t lah. X axis will be your t. So this is the function under y and t in the function of sin. So my graph will become something like this. This is how the graph will looks like. If you want to label all the amplitude here, you can do so lah. Right, I just want to focus on the shape of the graph. Alright, this is the equation for sin. This is the graph. Right. Now, how about number 2? This is the one we have to, right, a bit difficult. When the value of x is given here, number 2 here, it's not 0, but is x is equals to 0.25. So when x is equals to 0.25 meter, when you substitute in the equation, so my equation here will become 4 pi multiplied with 0.25. So this is where I have substituted in my equation with the value of x is equals to 0.25. So what happened to my equation is, so when I multiply, so I'll end up my equation here, it will become 2 pi t. This one, after you multiply, it 0.25 multiplied with 4, you will end up with 1. So it will become minus pi. How are we going to sketch graph like this? So the step is, firstly, when there's a face, when there's a face here, right? When there's a face, the back here. So the first step is removing the face first. Face ni, we remove temporary. So this is my equation, temporary. So my equation temporary without the face is function of sin. So what I'm going to do is I'm going to sketch the graph, sin, basic mathematical graph. Sin, maybe this one is amplitude is not the same. I'm going to redraw again. Right, something like this. This is function of sin graph. Now, after that, the first step is done. The second step is now we move back the face into the equation. Right? So how do we sketch the graph with the face here? So firstly, we have to look at the sign here. If it's negative, means we have to rearrange the axis. We have to move the axis. Right? So there's a face here, that means that we need to move axis. So negative represent where we should move our y-axis. This is our y-axis. So y-axis, we will move the y-axis left or right. So we can move our y-axis left or right depending on the sign here. So in this case, the equation sign is negative. That means that we will move our graph to negative, means we move our graph to the left, right? So I'm going to redraw again. I to extrapolate this graph, so it becomes suppose like this lah, back here. So now I'm going to move my graph y to the left because it's negative. So we move to the left. But how much should we move to the left? So it depends on what is the value here. In this case, it's pi, right? So we should move our y-axis to the left by how much? Pi. So what is pi? This one is considered as 2 pi radian. So if pi means it's only half of it, that means that negative pi, that means that we move our y-axis negative, move it to the left. How much? Pi. This is the this is the final position. So initial is here. We move to the left by pi. Right? This is our new graph. Right? This is our new graph for this equation when x is equal to 0.25. Right? This is the step that I want to explain. Okay, now let's take a look at the next question. Next question, this time they ask us to plot a sketch graph y against x. Like I mentioned before, if you want to sketch graph y with x, that means the t must have a value to substitute in. That's why they give you the value here. So I'm going to proceed with c. So this time I'm going to copy back the equation, main equation. Right? But this time I'm going to substitute the first part 1 when t is equals to 0. So what I'm going to do is substitute t is equal to 0 into our equation. Our equation will become something like this. 4 pi x. So when it's 0, 0 is a bit easier because you eliminate all the values there. So my equation now we get 0.5 sin negative 4 pi x. Now, negative, we have to move it outside, right? So once ever there's a sin something value here, if it's a negative there, we have to move it outside. So move it outside, I will end up with something like this. All right. This is my main equation now. So if I want to sketch the graph, so my graph will be something like this. This is y against x. Right? Just now it's y against t. So this is y against x. So my x is under the function of sin, but there's a negative here. So if it's sin negative, that means that it starts from negative side. This is how my graph looks like. Now, the next part is part 2. This time they give you t another value, but the t this time is 0.25 second. So 0.25 second. 0.25 second. So I'm going to substitute the value t 0.25 into our main equation, which is 0.5 sin 2 pi. The t here would be 0.25, then minus 4 pi x. This is our equation. So once we have done that, so this one 0.25 multiply with 2, we will get 0.5, right? Half. So what I do is, so I will end up with my equation will look something like this. 0.5 sin, this one will become pi over 2 minus with 4 pi x. This is my equation. Now I'm going to rearrange because we're supposed to sketch graph y with x, so x must be the first, rearrange first lah. So I'm going to do this way. I'm going to rearrange like this, or I recopy again. So my equation will become sin negative 4 pi x plus pi over 2. This is our face at the back. This is our face. Now again, there's a negative here with the x, right, which is our x-axis. So we don't want negative. So what we do is we need to move the negative out. So we will end up with 0.5 sin. This one without a negative will become 4 pi x. This one will become negative pi over 2. This one will become negative pi over 2. Why? If you expand negative back to the equation, I will end up with negatives. The same thing. I will substitute expand inside. You will get back positive here, right? Now this is my equations that I will sketch my graph. So when I sketch the graph y against x, so this is y against x. So what I do is same step. The first thing is there's a face at the back here. There's a constant at the back here. So what you do is, firstly, we sketch the graph. We move this one away first. Move this one away. So we only focus on this graph. So this is a graph sin. So sin and a bit of negative amplitude here. So the graph will look something like this. Right, this is the sin, negative amplitude here. Now once we have done that, now we have to bring back our face into our equation. This is our face now. So this one refer to where we should move our y-axis and how much should we move our y-axis. So in this case, it's negative here. Negative means again we move our y-axis to the left. If this one is a positive, we have to move our y-axis to the right, right, depending on the sign. So in this case, it's left. And then if it's left, how much should I move? I'm going to extrapolate the graph at the back here, right? I need to redraw a better curved line. Okay, so something like this. Now we need to move our y-axis to the left. By how much? By pi over 2. How do we know how much is pi over 2? So if this is the graph, this one will become 2 pi radian. So half of it will become pi radian. So half of pi, you will end up with pi over 2. This is the one, pi over 2. So I have to move my y-axis to the left because negative to pi over 2 radian. This is my new graph. Right, so I'm going to draw the initial line is here. Initial line, yeah? So we move half pi to the left because it's negative. All right. So once we have done that, so I'm going to rub off the graph here. So this is my new graph, right? This is my new graph for this equation. This is how we sketch the graph if there's phase involved, right? It's a phase involved in the equation.